Hey everyone, welcome back to Jetson AI Labs. We're really excited for today's episode. We've got a special show for you with a bunch of our summer interns from the Jetson team at NVIDIA. Wave hello everybody. Hey there. And this summer intern program has been interesting since, basically all virtual, and we've got a lot of interesting experiences from their time at NVIDIA that they like to share with you, along with some really interesting projects that they've been working on. So why don't we go around quick and you guys can just introduce yourselves really briefly before we get into the news. Tomasz, do you want to go first?
Yep, sure. So hi everybody, hi YouTube. My name is Tomasz. I'm originally from Poland. Right now I'm located in San Jose, California. And I graduated with master's from San Jose State University in computer engineering. And right now I'm an intern for 5 more weeks at the Jetson team, working as an embedded engineering intern. And later I will have some cool stuff to show you.
Awesome. Looking forward to it. Alexa, you want to go next?
Sure. Hi, everyone. My name is Alexa. I currently study electrical engineering at the Cooper Union, going into my last year of undergrad. And this summer, I worked as a hardware intern on the GPU products team, working on my Jetson Nano baseboard, which is an open source educational baseboard for the Jetson Nano. So I'll talk about that a bit more later.
Hi, my name is Mikyas Desta. I am doing my master's in computer science at Georgia Tech, and I have worked on a couple of projects here at NVIDIA, and I'll share that with you later.
Hi everyone, I'm Abhi. I'm an incoming PhD student at the University of Illinois, Urbana-Champaign, in the electrical and computer engineering department. And so I have 1 week left of my internship here at the Jetson team at NVIDIA, and then I'll continue there for my PhD. So excited to share my project with you as well.
Hey everyone, I'm Rishabh. So thank you, Dusty, for giving us the chance to come on Jetson AI Labs, first of all, because we were interns last year. I think technically not summer interns anymore. So we were fall interns last year. And I graduated with my master's in robotics from WPI this summer. So really excited to discuss my projects with you.
Hey everyone, thank you so much for joining. My name is Asawaree, and I was actually an intern last fall. So I joined full-time pretty recently, earlier this month. And I'm just excited to talk about my internship projects, and nice to meet you all.
Awesome. Thank you guys. And as always, we have Dana and Jim from JetsonHacks here. How have you guys been?
Doing well.
Doing great.
That's great. Okay. So the plan for today's show is essentially we're all going to go around and share what they've been working on, and you guys can ask them questions in the chat, which we encourage you to do. But before we get started with that, we just have a couple quick news items that we'd like to share that have happened over the past month. Probably the first one of which, let me pull up my screen here quickly. Jetpack 4.6 came out earlier in August here and has a bunch of new features, including support for the Triton inference server and a bunch of cool new things with how you can boot directly from NVMe as opposed to SD card on platforms like AGX Xavier and Xavier NX. And Jim, I think you had mentioned that you had created a video recently on that topic. Is that correct?
That is correct. There's an article up on the website and a YouTube video about native boot from external storage. So if you can keep your enthusiasm down about that, what it allows you to do is, using scripts on your host, you can flash your Jetson. I think they're both Xaviers, so AGX Xavier and Xavier NX, to boot from an external NVMe drive.
Yeah, that's awesome, man. That's been like a long-running request from the community, understandably, and we had to make a bunch of changes to the bootloader and kernel in order to enable that. So essentially, it used to be like you could have NVMe, but you could put your root file system on there, but things like the kernel or bootloader still lived on the SD card. So now essentially everything can go on NVMe and can be really fast. I personally always use NVMe on the Xavier devices and can get up to like 3.2 gigabytes a second read on those. So those are really fast. And then I should also mention we have a couple webinars out. This one on a Jetpack 4.6 deep dive that my colleague Suhas gave yesterday. You guys can watch that on demand. And in there is a demo of how he set up the NVMe and some other features, including over-the-air update using AB redundancy. So you can essentially have two images on the device simultaneously for secure OTA updates. And then coming up next week, we have another webinar on VPI and the new Python bindings for that. VPI, if you're not familiar, is the Vision Programming Interface library that it has backends for CPU, CUDA, and also the Computer Vision Accelerator engine on Xavier. And has a bunch of features in there for things like stereo disparity, optical flow, a bunch of pre and post processing computer vision algorithms that you can run. So I really encourage you guys to check this out because it's basically the highest performance computer vision library out there for Jetson today. And Dana, anything new in your neck of the woods?
Well, along with Jetpack 4.6, we have new released container tags for the Getting Started with AI on Jetson Nano course, and it's now in 4 languages. So we have an additional 2 languages from before. So it's in English, Simplified Chinese, Traditional Chinese, which is new, and Japanese, which is also new. So that's
awesome. Yeah.
The latest.
And along the lines of the containers, all the containers for 4.6 are now up. And there is actually something new with the containers that we've done is we are starting to transition over to having all of the CUDA libraries and cuDNN and stuff installed directly into the containers. So there are new L4T CUDA and L4T TensorRT containers out there now on NGC that have all of that stuff inside the container, which is how you would normally do it on like a PC or a server platform. It's just that previously on Jetson, we had mounted those all from the host. So in future releases, we're going to be migrating more and more towards that. We call it the fat container approach as opposed to like the slim containers, which we had been doing on Jetson previously. And the big advantage of that is that with the compute stack and CUDA and all those libraries bundled inside the container, in the future, you will be able to run containers that are built against different versions of Jetpack on the same Jetpack. So you'll no longer need to rebuild container for every new Jetpack version. You have a container that's built for 4.6 and 4.5 running alongside of each other that are independent and running independent versions of CUDA, which should make it a lot easier to deploy these types of applications. Okay, I think that's basically it for the news. I encourage you guys to check out those webinars, and if you haven't already, the latest updates from Jetpack 4.6. You can just typically apt-get install those without having to refresh your device if you so desire. Okay, so before we get too far into the show here, I do want to save as much time as possible for the interns to present all their great projects. So with that, we're basically going to go in order here as the Brady Bunch layout that we got going on. So Tomasz is going to go first and share with us what he's been working on at his time here.
Yeah, thank you. Yeah, so hopefully you can see my screen. Can you see my screen already?
There we go.
Yeah, so I have a little slide deck for you. So the core project I was working on was that sort of it's sort of jet racer style robot in that it is a RC car with Jetson on top of it. But yeah, here the goal was that the robot would serve as a as a reference multi-camera application for Jetson, and that people can hopefully take it and sort of build on top of it. So here you can see a custom Jetson NX board with GMSL2 interfaces. GMSL2 is sort of similar to MIPCSI, but it's sort of it's a different interface that's used more in automotive and industrial robotics. Yeah, as I said, the goal was to show a multi-camera reference application, and the challenging part was to offload all the as much of the compute load from the CPU and GPU to different accelerators that you can find on a Xavier. So hopefully at the end of it, as much as possible of the CUDA and CPU resources is left to the user. So you can do pretty cool stuff with it, and it will be available on GitHub by the end of my internship. But basically, using as little as a little more than one CPU core, you can basically capture 3 1080p 30 FPS streams, push it through two deep neural networks that are object detector networks, and map every image to a NumPy array, encode a video stream in with H.264 codec, and do all the file I/O for it, display everything, and and by the end of it, you're still left with most of your CPU power for your application. And I think the best part is that you can still run another full real-time network on top of it, because you're left with essentially 100% of your CUDA resources.
So, Tomasz, did you just use GStreamer and DeepStream for the camera acquisition, or how'd you do it efficiently?
That's the idea. GStreamer, NVIDIA released over the years a lot of components for GStreamer, and as of today, this is the best way to access the hardware acceleration for many of the computer vision stack. But the problem was that it was not necessarily the most friendly interface. So using my project, you'll be able to essentially instantiate a pipeline, and it will create a GStreamer pipeline dynamically under the hood. And what you're doing is essentially just getting a NumPy array from that pipeline, if that makes sense. So and yeah, and typically if you did that if you did that using OpenCV calls, it might be a little less efficient. And yeah, also you get all the results of the object detectors and file I/O out of the box. Here's sort of like a highlight of the internship. When you do an internship at NVIDIA, you get to meet with the CEO, which I don't know, I thought it was kind of cool. A really cool guy, by the way. Like if you get to meet him in person, like it's the coolest billionaire I know. And yeah, and the last thing, it's not my internship project, but it's a project I was working on recently. It's called JetDrone. So a thing that I thought was really missing in the Jetson ecosystem was a Jetson-based drone, and and not just the drones that were out there and that I was previously working on were sort of, you know, like a off-the-shelf DIY drone with just Jetson strapped on top of it, which firstly, it wasn't super. It didn't look super well, but also it's you didn't end up with the whole thing ended up being much heavier, and you basically ended up having with all those wires around it. So I thought it would be really cool to create a drone that is sort of Jetson native, and yeah, that's what Jet Drone is about. So right now it's just the hardware, but yeah, the whole chassis is 3D printable. So except for those carbon fiber tubes, and I will post a link later to that. The whole chassis is 3D printable, and you get stereo cameras right here, and later there will be code released for actually calibrating those and performing and calculating stereo disparity. And yeah, here you're probably familiar with that. You get XT60 connector for your battery, and this thing is a full Jetson Nano developer kit, which is connected to those two cameras, and yeah, I will release it probably later later this month, and yeah, hopefully that will be home to some cool applications in the future. I do have a video to show you if we. So yeah, that's basically the maiden flight of that drone. Right now, it's not super. It isn't doing anything super impressive, but yeah, the next step will be showing autopiloting the drone with Jetson on board, and then hopefully doing some cool computer vision stuff on top of that. Yeah. Cool. Also, if you have any questions about that, please feel free to drop comments in the chat.
Awesome. That's a really nice looking chassis. So did you like design that whole thing yourself, Tomasz?
Yeah, yeah. So it's designed. I designed it in Fusion 360. So so yeah, I will drop. I'll drop a link where you actually will be able. I don't know if am I still screen sharing?
There we go.
This is the 3D model. So I can share it. I can share it with you later, and you can export all those components as STL files and just print them. And yeah, those are the lenses for the cameras. And if we turn that thing here, then you can. This is a pretty familiar view for a lot of you guys, I think. This is just a Jetson Nano developer kit, and yeah. So the link will be somewhere in the comments. All right. I think I'm already over my time, so I will pass the mic to the next person.
No worries. Thanks, Tomasz. Those are really cool projects and great work. Okay, next we're gonna have Alexa talk about the custom PCB that she made for Jetson Nano.
Yeah, absolutely. Thanks. So I was an intern both last summer and this summer, and I worked on the same project, which is called my Jetson Nano baseboard. So the goal of this project is to enable makers to create their own hardware designs and like basically just design their custom PCB for the Jetson Nano. And so if you could show the GitHub, please. So here's it's on GitHub already. Y'all can star it, fork it, like start using this right away. So I was responsible for schematic, layout, verification, all that good stuff. So I actually do have the first E00 prototype here that was validated and the issues were fixed with it. So in the spirit of open source, I've shared all the documentation, all the files that I used. Also the issues that I found while doing validation are here. So you can check out things that were incorrect if you want. And yeah, so I think this is a really cool project in that it has the potential to enable more makers to get involved in hardware, which is something that is a little bit less developed than open source software. Open source hardware is, I think, not as common. And so I think we're lowering the barrier to entry in terms of open source hardware, which is really cool. I can talk more about the technical specifications if anybody is curious, but
yeah,
happy to answer questions.
I think we're also interested if, because I think Alexa, you're the first person on the show that actually is doing like hardware baseboard design and is designed a carrier board for the Jetson. So it'd be very interesting if you could just kind of like walk us through the process of what you had to do to design, fabricate, and validate this board.
Yeah, absolutely. So I actually have in the documentation, I have set up this file which basically goes through the process and like how you might approach designing the board. I think the most important thing for me was reading all the documentation that NVIDIA puts out. So there is like a product design guide for the Jetson Nano. There is like all these specifications. And so for me, it was my first time doing hardware design. So I had to learn about like schematics and layout and all that stuff. And I definitely learned a lot about for mostly high-speed signal routing, which is like a challenging thing. But initially in the ideation process, we knew we wanted to build a board that was a little bit easier to design than the Nano. So there are some features that the Nano has that this board doesn't have, like camera connectors, Ethernet, and DisplayPort. And there's some additional features that are more user interactive that this board has, like there's a servo header, there's some LEDs for toggling GPIOs, there's an OLED display, that sort of thing. And those features that are more user interactive fit with the goal of teaching people how to use Linux or Tegra and those kinds of features.
So you mentioned like this was actually your first time doing a baseboard design, which I find to be very impressive considering the high-speed signals and things like that. So did you do any other like test designs or other like really basic things to familiarize yourself with that, or just basically dive straight in?
I kind of, well, so how do I put this? The schematics and the layout for the Jetson Nano are already posted externally. It's already open source for the baseboard at least. So I reviewed those schematics. I tried to learn from what NVIDIA's designers had already done and understand why the circuits are like the way they are, so that I could replicate aspects that I thought would be good for my board and that sort of thing. I also made sure that like one of the great things about having an internship at NVIDIA is just the sheer amount of like knowledge that there is on my team. I have a lot of really smart people doing a lot of really awesome things. So I decided to take advantage of asking them questions and figuring out what they knew and how they could help me in doing this. I did design a few like smaller boards that were like turning on an LED, but I didn't get those manufactured. It was just like to get used to using KiCad and that sort of thing.
Okay, is that what software suite you used for this, KiCad?
Yeah. I chose KiCad because it's the free like open source like PCB designer that's the most common and has the most features. Like internally we use Cadence Allegro, but the licenses are like very expensive for individual makers, so like doesn't really make sense.
Yeah,
to release
that's
in
very
that file
thoughtful of you.
format. Yeah.
So, like, there's a lot of software people on the channel and in the community, and while there are a lot of hardware designers, they typically tend to more on like the professional side of things. And I can't recall if you have an electrical engineering background or not, but for somebody who's coming from software, but like wanted to get into PCB design, what like tips or guidance would you have for them, and like how do you even get started in such a thing?
Right. So my background is in electrical engineering. That's like what my degree is in. And I guess my advice to people starting out would be like choose a small project. Same thing with like a software thing. Like you wouldn't immediately like go architecting a whole database or something like that. You would like do a hello world program and like figure out if it works. And so I would suggest maybe building like a smaller board that would enable you to do something simple, like turn on and off an LED, or like I don't know, like control a motor, something like that. That's like very simple. And then once you have that down pat and you understand like how everything works, then you can go to like more complex signals and like start reading more about the harder stuff. There's a saying that's like, it takes less time to build a 4-inch telephone mirror than it does to build, a 4-inch than an 8-inch than just an 8-inch. So the idea is like by failing and by doing something small, you can like do a bigger thing later. Somebody's asking about the total cost in the chat. So for us, we paid $400 about on JLC PCB for 10 boards. So it works out to like $40 a board. So that's just like an estimate. There are definitely other manufacturers that will build this for you for varying prices depending on what their capabilities are.
And did they put all the components on it for you, or was it just the raw PCBs and you had to like actually assemble it?
The challenge with this was that JLC PCB specifically doesn't put some of the parts on the board that they don't have themselves in their library. So we did have to solder on some extra parts. So that is like a consideration, like for a maker, like if you don't want to solder the SODIMM connector on by yourself at home, you should probably find someone who's willing to solder it on for you.
Okay. The SODIMM connector can be a little tricky, I suppose, but
for sure.
Yeah. Awesome. So Alexa, one last question for you. Like, what future plans do you have? What are you planning to do next now that your internship's ended?
Well, I'm going back to school for my last year, so I'm excited to, spend some time learning and going more in depth in this. Yeah, and I hope to continue working with folks at NVIDIA in the future. I mean, I really enjoyed my internship experience, so it was great.
Awesome. Yeah, it was great having you. And it was great to have a actual like hardware project that I put out there. So, everybody from the team and the community really appreciates that.
Yeah, absolutely. Thank you.
All right. So, Mikyas, we're going to go on to you next, and you can talk about what you've been working on and what you plan to do next in the future.
Sure. Thanks, Dusty. So yeah, as I said, I worked on a couple of projects in NVIDIA. I'll talk about 2 of them now. The first project that I worked on is that it's a hand pose estimation. What a hand pose estimation pretty much means is that it's pretty much predicting the joints on your hand from an image. It's becoming popular these days because of the AR and VR, like the emergence of AR and VR. It has applications and human-computer interaction, sign language recognition, and also like remote surgery and those kinds of things. So when I started my project, what I did first is that I first researched on deep learning architectures that can that can do hardware acceleration with TensorRT, that can use TensorRT and that are fast on Jetson devices. And like there are a lot of papers that talks about hand pose estimation, but most of them can be categorized to 2 approaches. The first approach is the bottom-up approach, where you first detect the joints, and then you learn the relations or the associations between the joints. And the other approach is the top-down, where you first detect the hand and then learn about where the joints are. So I did the bottom-up approach. There's a project that has been done in NVIDIA by John Welsh on TRT pose. That's just a human pose estimation project. I followed that, and it uses ResNet 18 as its backbone and uses like attention mechanisms. So I followed that, and we collected our own data set inside NVIDIA, which is somewhere.
Mikyas, do you want to share your screen?
Oh, okay. I thought you were seeing my screen. Sorry.
Yeah.
Oh, I see. Okay. I thought it was shared.
No worries.
Okay, so you guys missed a little bit. So, okay. Yeah, so this is the project that I worked on, the hand pose estimation. So I was saying that we collected, somewhere around 2.6 thousand images or 2.7 images. We annotated them. Like we were annotating 21 key points on a hand. So as you can see here, we have 21 key points. We annotated and trained them. We did like some data augmentation to make the model work well. So as you can see it's working well and stable here. Once I finished doing that, I did some applications that shows how to use this. The first application that I've done is that the hand gesture recognition. What I did is that I pretty much made this Jupyter notebook where you can train your own hand gesture recognition or classifier. It doesn't need that many images. It takes the output of the pose estimation, and you can create your own hand gesture recognition. Pretty much, you can say this is fist, this is like, stop, with few data points. So that was working well as well. So you can go and take a look at it. I just used a simple SVM support vector machine for the classification. And then I used that application to do two more demo applications. The two demo applications are, the first one is that this cursor control, where it lets users control their computer screens using just their hand. It was pretty interesting because, as a use case, what I did is that I just bought a tuna sandwich online just using my hand. I didn't do any clicks, or I didn't use the keyboard. It pretty much is handy for in the COVID time, especially. So, and like on the right side, you can see that it's not just only clicking. You can also do zoom in, zoom out using your hand pose, your hands or fingers. The other application that I worked on is that simple mini pen type of application where you can draw, like erase, clear on your camera screen. Here on this video, are you guys able to see this video? Okay, cool. So you can see that, I'm just drawing on my screen, on my live screen. You can do rectangles, you can erase it, you can, you can do rectangles, you can erase, clear. So yeah, simple mini pen type of application.
And that's really cool.
Cool.
Yeah, I've tried this project, and it's a lot of fun to play around with. And I thought it was really interesting how you use the SVM on top to actually do the gesture classification.
Yeah.
What do you think was the most time-consuming or challenging part of getting this to work?
This was the most challenging was the data collection, annotation, and also, I've learned a lot from it. Like, this is just a real data. So like the first time I just tried it, it wasn't working, right? Like we had to take different angles for the data collection from different people. It was not generalizing at all at first. We had to use some data augmentation, like, we were masking the hands and throwing the hands into a different background so that it can learn with different backgrounds. And also the lighting conditions were also really mattering, because we didn't train it with many lighting conditions first, but then once we did the masking with different backgrounds, it was working well.
How did you annotate it? Did you have some kind of widgets that you kind of built in to kind of collect the data and, here's the tip of the finger, that kind of thing?
Yeah, so we made an annotation tool, like John Welsh made the annotation tool for me, and then we were able to go and annotate the data. So you just go click on the hand, and then you assign it a letter, and then once you assign it a letter, it was able to, we have 21 letters that corresponds to each joint on the hand, and we save that to a JSON file, and then later we train it.
How long did it take to train it?
It didn't take much, probably 3 hours to 6 hours. It depends on how many iterations we were doing. But yeah, 6 hours, I would say, is the average.
And you trained it on the Nano?
No,
or
we
elsewhere.
trained
Okay.
it in x86 machine,
All right.
GPU, V100 GPU machines. Yeah, but on Jetson, it's mostly the inference part. So this was my first project. My second project on DeepStream Dwarp Plugin project. And what a DeepStream is, for some of our audience that doesn't know it, is a multi-platform scalable framework that you can build and deploy AI-powered video analytics apps and services. So it has many plugins.
Mikyas, can you change the tab in your browser?
Okay, sure.
There you go.
So this is it. Yeah. Thank you, Dusty. So it has many plugins, and one of the plugin is the Dwarp plugin. What the Dwarp plugin does is pretty much it dewarps image to a different, it transforms them to a different type of projection. So you could have different type of projections, for example, a Panini, push broom, fisheye 360 type of cameras. You can have image, videos from those kinds of cameras, and then you'll be able to dewarp them to different projections, to perspective or push broom or Panini like this. The advantage of using this application, this plugin, is that some of the machine learning algorithms, or like object detection or people detection, kind of struggle on detecting on a fisheye camera or like in different projections. So you can project them to a different image or a different projection, like for example perspective, and you'll be able to detect it better. So as you can see from this example, while we were just using the fisheye camera, we were only able to detect 2 people, but after we dewarped it, we were able to detect more people, and also we were able to see the image better than like the fisheye 360 camera. So what I first worked on in this project is just updating the Dwarp plugin. Like it only had 3 types of projections. I added like 15 more projections, and then I just made this sample app where it shows how to use the Dwarp plugin, and also on top of that, how can we detect people, or you can do your own type of detection. You can use object detection or any type of detections from the DeepStream. It has this config file where you can just go and play around it, and if you have questions, let me know. Yeah, so it needs some kind of 3D geometric knowledge. I didn't have that knowledge, but there are a lot of smart people in NVIDIA. I was just going and slacking them about it, and they're pretty helpful on that. So yeah, this is the projects that I worked on. One thing I just want to mention is that I worked at IBM on research-oriented project before, and somehow how I differentiate what I worked on here is that here we focus on optimization, performance, and I'm glad that I worked on with real-time from data from the camera stream. Everything was real-time. When I was working in IBM, it was more of a research type of project, so we use synthetic data sets. Also, we weren't as much concerned about performance and optimization, and it was pretty cool to have to learn these techniques about TensorRT, and I'm grateful for that.
Awesome. Thanks so much, Mikyas. Really appreciate it. Okay, so next we're gonna have Abhi share what he's been working on.
Yeah, so hi everyone. So this internship, I was working on scene text recognition on the Jetson Xavier AGX board. And essentially, I can go over what scene text recognition means. What it's referring to is if you have a picture or an image of a scene and you see words in that image, the program is going to extract those words and display them for you. So if you've ever heard of OCR or optical character recognition, that's commonly used to take scanned images and extract the text, so you can edit them. And that's similar to what's going on here with scene text recognition, but the only difference is it's text that occurs in more natural scenes. So for example, reading signs like street signs or reading labels of shelves or examples like those. So those are instances where scene text recognition could be useful. How my internship started really was a lot of background research and understanding, what goes into this recognition and what goes into being able to extract text from images. And what I found out was there are two main steps in the process. The first is the detection, and then there's the recognition. So for the detection step, a deep neural network will extract where the text is located in an image and give it a bounding box. So in that, it's similar to most object detection algorithm or object detection neural networks that find bounding boxes for different parts of an image. So right now, the detection essentially outputs bounding boxes for the text in the image, and then the second stage of the whole pipeline is the recognition part. And in the recognition part, a separate neural network takes those cropped images from those bounding boxes and outputs the text from those. And that's more of a simple classification type neural network that works on doing that. So putting both of these together, you can get a really good scene text recognition system working. And that's kind of what my project was oriented around here. And then another major part of this project that I was working on is, as Mikyas just mentioned, we often focus here on NVIDIA on optimization and speed up. So I was using TensorRT to get these existing algorithms to work really well and fast on the Jetson AGX Xavier board. And I used the Torch2TRT repo for that and a lot of TensorRT API code as well in order to get that running. So I also have a little demo here that I can run and share for you as a video. Give me 1 second. Okay, do you see the screen up? And let me play it. So as you can see here right now, the detection is working on this image, on this video, and it's creating these bounding boxes. And then the recognition here is taking those bounding boxes and outputting text. You can see it's not perfect every time, especially while it takes time for the camera to focus, but eventually it does get the correct words. And you can see throughout this video, I'm just holding up different objects and having it read what's on the object, and especially for these crowded ones. And I think there's some Spanish words in here. It gets a little confused, but overall it's doing pretty well. And one thing that's not shown here is that the code can also, it tells you the confidence score for each of the words it's identifying. So we can always filter out, if it's not confident that this is the correct word, we can filter that out as well. I think this one, it performs very well because it's pretty clear in plain text, and you can see it gets it almost exactly right. NVIDIA Jetson AGX Xavier Developer Kit's quick start guide.
Yeah. That's awesome.
Yeah, this one's interesting. I thought I would give a fail case. So when you put it vertically, it doesn't show you the text. So that's something I think can be extended with this work I'm doing. I think the whole idea of the code I'm working on is hopefully after next week, by the end of my internship, it can be open sourced as well, and people can swap in and out the detection and recognition algorithms. So right now I might not work on vertical text, but if you train a detection and recognition algorithm to do that, I think it would be able to at some point.
So how does this actually work? Does it detect individual characters, or is it just like one model that spits out all of these words, or?
Yeah, so there are some scene text recognition that tries to create one model to spit out these words, but I think it works much better when you segment it into two separate models. You have the detection and then the recognition. So the detection model takes a frame and it's giving these bounding boxes. It outputs like the pixel locations of those bounding boxes. And that's what I'm displaying here in the image. That's one neural network. And then the recognition neural network takes the image, takes like the cropped image, like just what's inside of this bounding box, and then outputs the characters. So it's actually two separate steps that's doing this. And I think that works the best. And it's more modular as well. So you can swap out either detection or recognition, and test performances of the various models.
That makes a lot of sense, yeah. And so one thing that came across my path when I was working on ASR, or speech recognition, was that at the end of the ASR pipeline, it typically has like a lot of misspellings in it. But then you use like a language model that essentially classifies the outputs and gives you the closest English words. So I was wondering if, like, in your research, had you seen anybody using these language models to get correct misspellings or improve the accuracy?
Yeah, actually, in the research I've seen, I don't think they have used language models to improve the accuracy, but I do think that's an extension, especially when we're looking at the practical applications now. So, okay, let me stop sharing for a second, just speak. So I think in like the research community, when they're running these scene text recognition models, they have set benchmarks and data sets that you run the models through and get output text. And they can, determine the accuracy and compare state-of-the-art models. And I think in that case, they're just trying to focus on the recognition algorithm. But when it comes to like practical applications, I think you're right that it'd be a good idea to maybe have some language model at the end and being able to convert. Because as you saw in the demo video, not all the words are perfect. There were some misspellings. So having that extra step, I think, would really help in that application.
Awesome. Yeah. So you had mentioned that you are an incoming PhD student at University of Illinois, right? Do you have any ideas about what you might want to study or do for your thesis there?
I do. So I did undergraduate here at the University of Illinois as well. That's where I am right now in my apartment. And I think one of the projects I'm continuing on is in the human-centered autonomy lab here. And it's the project has to deal with human-robot interaction, and a lot of the projects in the lab are about autonomous systems and robotics. And I'm finishing up a user study dealing with like humans being able to speak and communicate with robots and seeing how humans perceive that interaction. So that's an interesting project that I'm working on in that lab right now. And then another lab I'm looking at works more with hardware acceleration and machine learning algorithms and heterogeneous computing. So a lot of like FPGA hardware and trying to create an experiment with, architectures that can help machine learning and AI run faster. So those are the two research areas I'm looking into right now as I start my PhD.
Awesome. Well, we wish you the best of luck with your program there, and look forward to seeing and reading any research that you come out with in the future.
Definitely. Thank you.
Okay, so next we're going to talk with Rashab and Nasa, and these two are interesting because they were interns last year and they are now full-time employees at NVIDIA. So, welcome aboard again. It's great to have you guys back and formally part of the team full-time, and it's been great working with the both of you since you've come back to the team. So first, Rishab's going to talk about what he worked on during his internship, and then we'll take it from there.
Yep. Thanks so much, Dusty. Yeah, glad to be back. So I'm going to talk a little about the projects I worked on last fall during my internship, and they were sort of split into two parts. So just give me a second to share my screen. Can you guys see my screen? Can you guys see my screen?
Sorry, wrong screen. There we go.
Okay, yep, no problem. So yeah, hi everyone. So I worked on maybe 2 projects during my internship at NVIDIA. Like the first one was basically developing ROS2 packages for deep learning related applications on NVIDIA Jetson. And it was, the motivation behind that was mainly to enable like roboticists who getting started with AI to sort of use the Jetson series of products and use ROS2 with it in their own entire pipeline. And the second one was pretty interesting as well. It was on validation of the sim to real bridge using a simulation platform called Isaac Sim, which NVIDIA developed internally. So yeah, so the first project which I just told you about is like the ROS2 based project for AI-related applications on Jetson. What the main objective over here was to sort of develop packages for classification and detection of objects with the ROS2 framework. So I'm not sure everyone may be familiar with what the ROS framework usually is. So if you, for example, working with a robot and you know, like you've got multiple sensors, you've got a lot of processing which is going on. The robot could sort of maybe localizing itself in an environment using camera information, LiDAR information, and wheel encoder ticks. So there's a lot of things going on. So usually debugging sort of very big applications in which there's a lot of sensor input and output gets complex. So the ROS system proposes is sort of you distribute all these problems into separate code bases, which you call nodes, and you allow these nodes to sort of communicate with each other over topics and images, topics like images. So the main objective which I sort of undertook over here was, given like an image stream coming in from maybe a camera or from a file, can you have like an object detection and classification node built up in ROS, which can let you do these functionalities here? So I worked on 4 packages. The first 2 were just simple classification and detection, and the next 2 were accelerated classification and detection using Torch to TRT, and that used like the Tensor RT runtime environment and engine in the backend, which really gave us a good speed up in terms of throughput and reduce the latency. So sort of able to get real-time performance, and it was pretty cool. And yep, so the next part of my project was mainly on the side of validating the sim to real bridge. So it was really interesting because the main idea behind this was, can you sort of gather data in a synthetic environment, in a simulated environment, and then can you train a model and check if you can actually deploy this model in the real world and sort of how well it performs. So over here, I use the platform called Isaac Sim, which is NVIDIA's own platform for simulation, and I was blown away by the photorealism and the amazing quality and attention to fine detail in this platform. So towards my screen at the center, sort of you can see the simulation environment which has been set up by me in the Omniverse kit, and that there's a description of all the physics, all the lighting, texture, and all the other aspects in your simulation too, which is towards the right. So I'm going to sort of just show a quick video of how an important component called domain randomization and synthetic data generator actually work. You can actually acquire data from a camera perspective on the chatbot, and you can then save that data and train a model on it. So this is actually the perspective of the chatbot which you're looking at over here. And okay, so yeah, so perspective of the chatbot is what allows you to sort of get a lot of synthetic data. I think there was a problem with the video, but in the blog as well, I can show you what the synthetic data acquisition looked like. So you just sort of import your chatbot into this Isaac Sim environment with the other objects which you want to add to the scene. You then correct your physics as well, which you want the objects to exhibit. And then you can just sort of add domain randomization and collect data. And then you can train your own model. So the next step actually is to sort of deploy your model in the real world. So what we did here, we used the train model on synthetic data, and we wanted to actually deploy it on a chatbot in the physical world. So yeah, and these are like a few samples which we actually got from Isaac Sim. So towards the left, we have like, so the left images and the images at the center are sort of images in simulation. So you can actually see the quality of what objects you can get. Like it's pretty clear what features you're looking at, and it's very photorealistic. And towards the right is actual real world data which we acquired with the chatbot. So some of you might have noticed like there's a pinkish tinge in some of the images in the real world, and you can actually add that as a compensation in domain randomization, even while getting synthetic data. So that was pretty cool. And so this is a video of that trained model on synthetic data actually being deployed in the real world, and this is what it looked like. So you can see like the JetBot sort of recognizes the objects and accordingly avoids a collision with them. And it was pretty cool because it's only seeing data in the synthetic world, and the environment too, which it was trained on, is really different from where it has been deployed. So that sort of shows you that how well it's learned the features.
So Rishabh, what aspects of the simulation do you feel are important for the sim to real transition to work?
Sure, yeah, that's a really good question, Dusty. So I think one of the most important aspects which we initially figured out was we didn't even use the component called like the domain randomization. We sort of were trying to fix objects in the scene itself and just see if we could build the model. So what happens in that case is there's not a lot of variation in features for which the model can sort of generalize well in the real world. So that played a critical role, like changes in lighting, texture, and object scales. So those were very important. And so this was, I think this made a lot of sense in general, that it's pretty common sense that you would want at least a good similarity between the real world and your simulation. But a few other features which we found out which were important, like so when you look at the objects in terms of the JetBot's perspective, you want to make sure that your camera calibration is done correctly in simulation as well as in reality. So in case you don't do that, then you do get some inconsistencies in what the JetBot perceives the environment to be. So I think the photorealism which Isaac Sim provided along with synthetic data and domain randomization in the environments were very important for sort of the sim to real bridge to actually work. In case you use like in a simulation environment like Gazebo, which is popular in robotics, it's not even close to what photorealistic and attention to quality Isaac Sim provides. So you sort of can't expect to get results like that in any case. So
yeah, I've used Gazebo in the past, and you're exactly right. The graphics are subpar, although that one does run on the Jetson.
So
yeah, if you have an RTX card, the Isaac Sim is all the way.
Yeah, and these are the sort of public repos which are already available for the work I completed. So this is like the ROS2 node for object detection. And it's pretty much real time, as you can see in the image right here. And also we had blogs which we published along with all the work. So it's there for the Isaac Sim work which we performed as well. So here you can sort of, it's a step-by-step guide literally to actually import the JetBot into an environment, build and simulate objects and provide randomization too. So yeah, I think that was it for me in terms of my project. The most interesting parts during my internship were obviously getting to interact with many teams, because I think the people at NVIDIA are really smart. And when we came in from sort of academics, we were learning about deep learning, machine learning, robotics. It had been a lot of focus on training, on understanding what the concepts are in terms of theory. But we got the chance to actually understand the problems related to deploying neural networks, which was, we could really gain more appreciation for that, like how do you construct the entire pipeline end to end and work on it. And my 2 cents for anyone who sort of wants to get started on robotics and AI in general is things do tend to be pretty complicated. I think you might get overwhelmed looking at ROS and like deep learning. There's so much going on. So pick up a simple online course which will give you sort of the basics, and try to work on a simple project as soon as possible, because doing a project and sort of seeing it working is very important for you to stay sort of motivated throughout the way, and you can build on it, and you'll surely make progress that way. So yep, thanks a lot, guys. Let me know in case you have any questions.
Awesome. Thanks, Rashab, and it's been great working with you since you started back here. Thanks again. Okay. Last but not least, we have Asa up next to talk about what she's been working on. Thanks for being patient and joining us here, Asa.
Hi, thanks, Dusty. So before I jump into what I worked on during my internship, just wanted to spend a minute talking about the transition for me from being an intern last fall to joining full-time this fall. So after I finished it was a long internship, about 4 months. It was a semester-long thing, and that ended last December. I had a semester of school left. So I went back to Georgia Tech, finished my master's, and graduated this May. And so the transition for me, because it was part of the same team, I was joining the same team, I knew the people, I knew the kind of work they're doing and the kind of work I would be interested in doing. So it was pretty smooth in that sense. And because it was an online internship during COVID last year, I had been sent everything I needed. So I had my Jetson Nano, NX, the JAX, the Xavier, and I had configured all the libraries. Everything I needed was already ready. So for me to start earlier this month as full-time was just easy because I could start straight away. I knew what I was doing. But yeah, super excited to share with you what I worked on last fall. And I will be sharing my screen. Let me know if you can see this. Great. So the first project, I developed ROS2 nodes for DeepStream applications. Specifically, the applications I was working on was one for object detection and one for attribute classification. So the objective of the first ROS2 publisher I wrote was to be able to detect 4 classes of objects, and these were for outdoor street, like traffic scenes. So the first type of object was a car, people, road signs, and bicycles. And for every object of type car that was detected, the next inference engine, which was the classification task, would then kick in, and it would tell you what kind of car it is, the color, the make of the car. And so the objective of this entire project was to show that you can have ROS2 nodes working seamlessly with DeepStream, so that eventually if you have more ROS2 subscribers that require these kind of the object detection output or the classification output, could just pick up whatever it's seeing in the scene and act based on that. And so on the screen here, you can see one of the blogs that I wrote for this project, and I will be showing you a quick video about the output. It's a short video, but I'm hoping here you can see the bounding boxes around, let's say, people on the left over here, and then it's picking up a car. It's telling you it's a white sedan. And so all this output would be published as a ROS topic to a subscriber that could then pick up this information and do whatever downstream action is required. So this was my first project. For the second,
which model was that? So was it one of the TLT models or?
No, so the TLT model I worked on is the next project, and I'll talk about that now. And this was just one of the DeepStream Python bindings that I used.
Oh, gotcha. Yeah. No, this DeepStream node, we've actually already used this multiple times in ROS. So it's super convenient because DeepStream basically has the highest inferencing performance that you're going to find on Jetson. Oh,
yeah, absolutely. Yeah, I'm not sure if you could see in the video, but I've mentioned the average rate of detection and the publishing output. And yeah, this is definitely, you can use this for real-time applications.
It's like 165 frames per second, which is really good for detection.
Yep. And so part 2 of so this was the next project that I worked on. And that was, the objective was to have a JetBot navigating in an indoor environment, like in a house, for example. So we actually got a JetBot, I assembled it, and that was pretty fun to see it just moving around. And for the next project, the objective was to integrate ROS2 with the transfer learning toolkit as well as DeepStream. So you wanted DeepStream inference to be running on ROS nodes. And the 2 parts of that project were, firstly, to train a model for the task at hand. So for me, I used the MIT Places dataset. It has over 300 classes of indoor scenes, and I took a subset of 8 of them. And so I trained a model on detecting like just indoor house scenes. So there was a kitchen, a bedroom, bathroom, garage, stuff like that. And then I optimized it using TensorRT and deployed this on the Jetson Nano on my JetBot. And so I have a video to share here as well. This is the output. And so my house was too messy at the time, so I just pointed like the JetBot camera at a virtual scene and had it detecting. I hope on the right you can read, it's detecting kitchen right now. There's some error there. But the idea of this project was, corridor was another class that I had to detect. The objective of this project was that anyone should just be able to define their use case, find a data set, train a model on it, optimize it using TensorRT, and then you'd have ROS2 subscribers. That was the second part of this project that simply subscribed to whatever the camera is seeing at this point. And they could just perform simple tasks. Like they could stop, you could have the JetBot stop when it saw the kitchen, or maybe turn right when it sees the living room, stuff like that. So after working on these 2 projects, I realized how much post-processing there actually is, because it's not just having the demo work and presenting it to people. You have to kind of write a blog for it, explain, your GitHub has to be just clear enough for anyone to pick it up and start working straight away. We had to make Docker containers so that developers could, just use whatever they had, like plug in their models and then use the same pipeline that we had created. But all extremely interesting, very cool tech research going on at NVIDIA. And feel free to ask me any questions at this point. That's from my side. Thank you so much for listening.
Sure, yeah. I especially like that scene recognition model. Was that basically just like a ResNet that was trained on different scenes?
Yep, that was just the simplest, an 18-layer, like ResNet 18.
Awesome. And do you think that could even be used for something like robot localization or other applications than just simply scene recognition? Or how would you see that being used?
Yes. So I use the transfer learning toolkit for this, NVIDIA's TLT. And it already has, so I used ResNet 18 because it was a very simple like classification task. But for more sophisticated tasks, it has, PeopleNet, it has people detection, object detection, segmentation. And so it's as simple as taking a pre-trained model from the transfer learning toolkit, any model of your choice, a complex one as well, and training it on your own data. So yeah, It's just like a plug and play. Mm-hmm.
Awesome. Well, thank you very much, Asa. Anybody else have any final questions for us? As usual, we're over time here. But this has been a great episode. Jim, Dana, any final thoughts or questions you want to ask these guys before we go?
I think I might be talking to a couple of them soon, just for my own projects. I'm very interested in a lot of this, especially the deep stream.
Those are great projects, man. I liked them. Enjoyable.
Yeah, you guys all did a great job, and it was a real pleasure for us to be able to work together. And we wish you all the best of luck after your internship ends, and you go back to school or whatever you end up doing. And hope that we cross paths again soon. All right. Well, thank you, everybody. Thank you to all the viewers who joined us today. And if you have any questions down the road, feel free to reach out to us on the forums or on LinkedIn or whatnot. Leave comments in the comments section, and we'll get back to you. So thanks, everybody, for joining, and we'll see you next time. Thanks.
Thank you.
Everybody wave.
Thank you.